Hello everyone. Today we discuss on unit number 2, numerical methods. So in that numerical methods, the first part is numerical solution of system of linear equation. You know that system of linear equation, but there are some direct methods and indirect methods. Before that system of linear equation we solved in 12 by Cramer's rule or by matrix methods. Now there are some new methods. Some are direct methods, some are indirect methods. So indirect method, the Gauss elimination method is there. You also know that this Gauss elimination method, but in that unit you have to see this method by unique way. You have to solve by unique way. Second one is Cholesky method. These are two direct methods. Then two are indirect methods. Indirect methods mean iterative method. There are iterations. We have to find the solution by iterations, and we have to stop our solution when we get the same solution of two iterations. And second one is first one is Jacobi method and second one is Gauss-Seidel method. There are many applications of this numerical system of linear equation. The applications of structural problem, finite element method, find the current in the electrical circuit. That are the applications, or many applications are there that are applications of numerical solution of system of linear equation. Now today we see the only one method, that is Gauss elimination method. So see that first we consider system of equation 3x3 system, that is there are three unknowns. Unknowns are x, y, z, and there are three equations. Okay, so these three equations are there. a11x plus a12y plus a13z is equal to b1. This a11, a12, a13, b1 all are constants. Similarly, a21x plus a22y plus a23z is equal to b2. And third one is a31x plus a32y plus a33z is equal to b3. These are three equations. Now we have to solve these three equations and we have to find the value of x, y, z. So first step is that every time we have to divide equation 1. Divide equation 1 by a11, that is this a11. After dividing by a11, the coefficient of x is all the times 1, and remaining part is like that, plus a12 upon a11, y as it is, plus a13 upon a11, z is equal to b1 upon a1. We get this type of equation for every system of equation, that is coefficient of x is 1. Now second step is that we have to eliminate x. We have to eliminate x from this equation number 4 and from this equation number 2. So how to eliminate x? All the times coefficient of x is 1 and coefficient of x is here a21. So we have to multiply by a21 to this equation number 4. Then coefficient of x is a21 here, and here coefficient of a21 is x. Coefficient of x is a21. So coefficient becomes same of equation number 4 and equation number 2 after multiplying by a21 to equation number 4. Then to subtract equation 2 from 4. To subtract equation 2 or to eliminate x from equation 2 and equation 4, multiply equation 4 by a21 and subtract from equation 2, x become eliminated. Similarly again, see the equation number 3, we have to again eliminate x. The coefficient of x is here a31 and coefficient of x is here 1. After multiplying by equation 4 by a31, then coefficient of x of equation number 3 is a31 and coefficient of equation 4 coefficient of x is again a31 after multiplying. Then same procedure is here. So we have to eliminate x from equation 4 and equation 3. Multiply equation 4 by a31 and subtract from equation 3. Again x is eliminated. Then we get two equations. Which two equation? Here x is eliminated in that equation 4 and 2, and here again we eliminate x from equation 3 and 4. So we get two equations of the form only y and z because x is eliminated in both the parts. Now we get that type of equation. I'll say it is C1 y, C1 C2 be the new coefficients. By multiplying subtracting we get this C1 y plus C2 z is equal to D1, C3 y plus C4 is equal to D2. That is new constant. We get two equation of the type y and z. Again we have to eliminate y now. We eliminate x first, now we have to eliminate y. That we have to divide equation 5 by C1. Again we make the coefficient of y is 1. Similarly we make here coefficient of x is 1. Again similarly coefficient of y is 1. By dividing by C1 we get y plus C2 by C1z is equal to D1 by C1. Now we eliminate y from equation 6 and 7. Equation 6 the coefficient of y is C3, equation 7 coefficient of y is 1. So we have to multiply equation 7 by C3, equation 7 by C3 and subtract from equation 6. Then y is eliminated, and when y is eliminated only remain one variable which is z, and right hand side that is we get the value of z. Once we get the value of z, we have to use back substitution. See that once we get z, if I put z here, then we get the value of y. Means in equation number 7 if you put z, we get the value of y. Now we get two values y and z. Again we put y and z in equation number 4, we get the value of x. That is values of x, y, z be the solution of this system of equation by Gauss elimination method. So in theoretical part it may quite difficult, but in the example we directly very easy to solve the example by Gauss elimination method. So I take example. Solve by Gauss elimination method. It's 2x plus 4y minus 6z is equal to minus 4. Then x plus 5y plus 3z is equal to 10. And last one is x plus 3y plus 2z is equal to 5. This is system of linear equation, and we have to solve it by Gauss elimination method. First step is that we have to give it as equations. Equation number 1, 2, 3. Right? Now, our step 1 is that, and directly write here step 1. We have to eliminate x. We have to eliminate x from equation 1, 2 and 1, 3. So first step is every time divide by coefficient of x. What be the coefficient of x in equation 1? Here is 2. So every time divide equation 1 by 2. 2 is the coefficient of x in equation 1. So we get x plus 2y minus 3z is equal to minus 2. This is equation number 4. Right? Now, this is our first step. Every time divide by coefficient of x to equation 1. Then, next step is that I write this is our step 2. Next step 2 is for what? We have to eliminate x from equation number 4 and from equation number 2. Now here, see that the coefficient of x in equation number 2, it is already 1. It is already 1. If it is 2, 3, 4, whatever, we multiply by constant to this equation and after subtracting x is eliminated. But in that example, the coefficient of x is already 1, so multiply step is not there. We directly subtract here. So subtract equation 4 from equation 2. Because of what why we directly take subtraction? Because multiply by equation 4 by 1 for what? Because the coefficient of x in equation 2 is 1. So multiplication part is not there. We directly subtract equation 4 from equation 2, because coefficient of x here 1, x is 1. So after first I write both the equations. X plus 5y plus 3z is equal to 10, and our equation number 4 is x plus 2y minus 3z is equal to minus 2. So after subtracting, see that x is eliminated here. 5y minus 2y becomes 3y, 3z minus plus 3z becomes 6z, and 10 minus plus 2 become 12. This is the equation number 5. 3y plus 6z is equal to 12. We get equation number 5. Now similar step is there. Similar step is used for equation number 3 and 4. Now see the coefficient of x in equation 3. Again coefficient of x in equation 3 is also 1. So no multiply step. We directly subtract it. So I write here step 3. Subtract equation 4 from equation 3. Multiply step is not there. Then I write first equation number 3. X plus 3y plus 2z is equal to 5, and equation number 4 is x plus 2y minus 3z is equal to minus 2. So after subtracting, here x is again eliminated. So 3y minus 2y become y, 2y minus 2z minus plus 3z become 5z, and 5 minus plus 2 become 7. This is our equation number 6. Now this is equation number 5, this is equation number 6. Now x is eliminated. Now we get two equations of the type y and z. Now second part, that is x is eliminated. Now second we have to eliminate y. So I give it as a step number 4. Step number 4 is for we have to divide. See the equation number 5 now. The equation number 5, see the coefficient of y, which is 3. We want which is 1. So divide equation 5 by 3. Make the coefficient of y is 1 every time in equation number 5 only, not 6. So after dividing by equation 5 by 3, we get y plus 2z is equal to 4. This is our equation number 7. By dividing by coefficient of y in equation 5. Now our next step 5. We have to eliminate y from equation number 6 and equation number 7. 7 is our equation number 5 by dividing. So we have to eliminate y from equation 6 and 7. Again multiply step is not there, because in equation number 6 coefficient of y is already 1. If here is 2, 3, 4 or whatever coefficient, we multiply by that constant to this equation and then subtract. But here already coefficients of y is 1. So directly the subtract step. Subtract equation 7 from equation 6. Then I write first the equation number 6. Y plus 5z is equal to 7, and equation number 7 is y plus 2z is equal to 4. So after subtracting, here y is eliminated. So 5z minus 2z become 3z, 7 minus 4 become 3. So you get 3z is equal to 3. So after dividing by 3, we get z is equal to 1. Then using back substitutions we have to find y and x. So put that value of z in equation 7, put z is equal to 1 in equation 7. Then we get y plus 2 into 1 is equal to 4. So y plus 2 is equal to 4, that is y is equal to 4 minus 2, which is 2. So you get y is equal to 2. Now put the value of z is equal to 1 and y is equal to 2. Put y is equal to 2 and z is equal to 1 in equation 4. So fourth equation is there. So x plus 2 into 2 minus 3 into 1 is equal to minus 2. So x plus 4 minus 3 is equal to minus 2. So 4 minus 3 is 1. So x plus 1 is equal to minus 2. So x is equal to minus 2 minus 1 become minus 3. So this is the value of x, this is the value of y, this is the value of z. So finally I write here solution: x is equal to minus 3, y is equal to 2 and z is equal to 1. Be the solution for this linear system of linear equation. Just we revise it. So three equations are given here in terms of x, y, z that are unknowns. Then our first step is that we have to make the coefficient of x is 1. So we divide by 2 here. Then the equation is x plus 2y minus 3z is equal to minus 2. By dividing by 2, give it as equation number 4. Now second step is that we have to eliminate x from equation number 2. We have to eliminate equation number 2 and equation number 4. So for that we have to make the coefficient of x in equation 2 and equation 4 become same. But already here in the equation 2 coefficient of x is 1 and all the times coefficient of x in equation 4 is all the time is 1. So here is 1, so we use directly subtraction. If it is other than 1, then we have to multiply that coefficient to this equation and then subtract, then x is eliminated. See that here no multiplication part is there, we have to directly subtract equation number 2 and 4. Then x is eliminated, we get equation number 5. Similar step, again we have to eliminate x from equation number 3 and 4. So we have to make the coefficient of x become same. Here already coefficient of x is 1. If it is other than 1, then we have to multiply to this equation and then we subtract, but it is already 1. Again we use direct subtraction. Subtract equation 4 from equation 3. Then x is eliminated, here we get equation of the type y and z. Again equation number 5 become type y and z. We get two equations of the type y and z, 5 and 6. So elimination of x become over. Now next part is elimination of y. So see the equation number 5. See the equation number 5. The coefficient of y is 3. So make this coefficient is 1. To make this coefficient is 1. So for that we divide by this equation by 3. Then after dividing by 3 we get y plus 2z is equal to 4. This is our seventh equation. Now we have to eliminate y from equation number 6 and 7. So for that we have to make the coefficient of y become same. Here is already 1. If it is other than 1 here, then we suppose here is 2, then we multiply by 2 to that equation, then coefficient becomes same, then we subtract, but here already 1. So direct subtraction equation number 6 and 7, that is subtract equation 7 from equation 6. So after subtracting, y is eliminated, we get 3z is equal to 3. Then that is z is equal to 1. Back substitutions used here. So put z is equal to 1 in equation 7. We can put any one of them equation 5 also there, 6 also there, 7 also there. Put anywhere of the value of z, then we get the value of y. So here I put in equation 7 z is equal to 1. Then we get y is equal to 2. Again use back substitution for finding the value of x. We get y, we get z. So again we put in equation 1, 2, 3, 4. you can put any of them in equation, but I put in equation number 4 because the coefficient of x is every time 1. So put y is equal to 2 here, z is equal to 1 here. Then we get the value of x is minus 3. That will be the solution of given system of linear equation. So there are next method we solve that, see the method in next lectures. Okay, thank you.